So related to the last slide, thinking about negative space and map balance and map elements, comes this idea of, well, where do we put the different map elements, and are there different ways we can configure them to use the map space well? And we see three different examples here given California. So California is a state that's oriented more north-south than it is east-west. So here we're faced with the best choice would be a portrait orientation, given portrait versus landscape. So then, given the size and shape of California, where does it best fit on that canvas? If it's a regular sheet of 8.5 by 11 paper, or if it's a poster, 3 feet by 5 feet, or whatever dimensions it is, where does that fit within the larger canvas, and where does it leave room for other map elements? Title, legend, photos, again, whatever, inset maps, whatever kind of information you might want to have on there, visual or graphic information. Where do you have room for it? And so there's three different examples here of California oriented with columns of space that could be used to house different map elements. And I think I'd hope that you would agree with me that the ones on the left and the right are superior to the one in the middle. Okay, they just look better. There's a good balance of materials going on there, balance of space. Which one would you choose, the left or the right? Is very much a personal choice. But those two are probably going to work out better in the long run than the one in the middle. Okay, the orientation where you have the map, the main theme of California shoved right up against the top. It's awkward. It leaves a weird geometry to fill. It leaves weird negative space that you have to handle. Whereas if you draw it down from the top more towards the bottom, that's where the other two are, and they're both trade-offs between locations of California and creating negative space on the map. So hopefully this is something that will make some sense as you're considering whatever your study area is, your project, wherever it's focused, that geometry, how does it fit onto a printed sheet of paper or a poster or a screen, whatever you're designing for? Where does it leave room for the other map elements, and what other map elements do you want to include on the map to help assist the reader in understanding the map theme with more clarity, or maybe a little bit more broadly, to give a little bit more context to whatever that information is? That's what we can use negative space map elements for. Fill it with things that are useful. And where those things go largely depends on the geometry of your study area, of the theme that you're trying to get across by creating the map in the first place. So we make another transition. We're still interested in visual hierarchy, but now we're going to focus a little bit more and more formally on the symbols themselves, how we handle them, what they are, and what they can do to emphasize whatever they're trying to depict in our map, whatever we're using those symbols for. What are some of the ways that we can manipulate those to make sure that they're noticed, or make sure that they're sent into the background just a little bit in order to help support the map theme and the objective of getting across whatever kind of information we need to visually. So symbolizing for hierarchy, well, what we're trying to do, remember what hierarchy is all about, we're trying to make things stand out from the background. So how can we achieve that? We can achieve that by manipulating color, the contrast between colors, forcing things into the foreground or the background, using manipulating the size or thickness of lines or objects, using different symbols, different fonts, and the spacing or grouping of those things on the map. And so here with these four little diagrams, we can see a lot of information related to that. So in two different sets of polygons, the lower set has a highlighted line around them. So we're seeing those emphasized against the background. They stand out better against the background than the upper two color polygons. The upper two tend to blend into the background more. So just a little subtle effect like that, just creating a border around an area makes it stand out against the background. Using different thicknesses or weights of lines there in the second diagram, whether the line is interrupted as dots or not, if it's a different color that is contrasted against the background well, or if it's a color that tends to blend into the background. Those are things that we can use to manipulate line or linear features, so road networks, streams, things like that, either to make them enhance visually against the background or to fade into the background. They may be not as important, but we need to know that they're there so we can de-emphasize them and push them back in the visual hierarchy. Third diagram is kind of combining those ideas of using a border, using different colors to pop out against the background or to fade into it. And on the right, different kinds of type or fonts will obviously tell us, something about what's on the air surface. We can again manipulate those to make them stand out by making them bolder, heavier lines, darker lines, making them capital versus lowercase, using italics or not, using a color that blends into the background or not. So this, we want our symbols to either pop out or not, but we want them to be there so that they're useful for understanding what's going on the map, one way or the other. It's just how we choose to emphasize them. If we need to emphasize them, we can tweak all those things just very simply in ArcGIS and most GIS programs. Similar to what you might do if you're creating a PowerPoint slide or a PowerPoint-based poster. How do you make things stand out? You use the same principles there as you would in a map. It's all boils down to graphic design. It's just that here we're doing graphic design and trying to indicate space and spatial relationships at the same time. So when we're symbolizing features, there's some subtle things that we can do that seem subtle, but they're very distinct in making sure that our audience understands when things are important, even if we're using the same symbol to depict something across space or the same type of a symbol across space. So we've got two different clusters of objects shown here. The top two diagrams are together and the bottom three are together in separate groups. The top one, we've got some phenomena in space that we're describing using point locations, and we want to emphasize one location over the others. So on the right, we see a square of the same color, and we're saying there's something different about that spot. It's an important location, but there's something different about it, so we use that symbol to make sure the viewer sees it. That's not as visually grabbing. It doesn't get you as much as the one on the left. When we change the color from blue to a pink, that pops out a whole lot better. Okay, so down on the bottom three diagrams are kind of showing the same area, the same distribution of point locations, but doing it in different ways. So the one of those three on the upper right is showing things using different colors. So there's same point locations, but different colors indicating something's different about that. And that's very much something that stands out against the background. It's very clear to see those differences. Just to the left of that, the same distribution of points, but we're varying size. It works, but it's not as appealing. It's not as fundamental. We don't really grasp the differences as well as we can with color. And related to that, down below it, the same distribution of points again, using different shapes, the same color, it does show distinctions between the point locations. But again, the color just seems to pop out better. All right. But those are things that we can vary quite easily in a GIS system when we're symbolizing in vector format the size, shape, color, and what we might call the texture or patterns within the symbols or within the colors that we use on the symbols. We can vary all of those things to make the symbols stand out from one another in different ways to help us explain spatially whatever it is we're trying to depict on the map. And so right into that, differentiating our map objects, and in particular, we're looking at vector format data here, varying the shape, the type and size of the line, patterning, the texture, colors, or the font sizes, font styles, font shapes, all of that jazz. We can change all of those things that, and as you can see depicted visually below that, shape, size, thickness, line type, color, pattern, and the font, different examples of those. So hopefully this is something that you may think, well, that's obvious, but it's also very subtle. Okay, the things that we can do as a cartographer, as a map maker, trying to visually explain and describe spatial data and changes in spatial data or landscape phenomena, the use, or the choices that we make in the uses of these symbols and how we choose to symbolize them is really fundamental to our map user being able to easily understand what that information is and to see what's important against what may not be as important. So the theme of the map against the background, we can really emphasize the theme by manipulating these characteristics of the symbols. So what types of vector symbols are appropriate for what kinds of data? If you can remember from statistics, we have nominal, ordinal, and interval and ratio levels of measurement. And what this slide is showing us are really good examples of symbols associated with each of those. So let's start at the top. Look at the nominal or categorical level, where each thing is an individual symbol representing an individual object or feature on the Earth's surface. And over on the right-hand side of the slide, we're seeing a screen capture from ArcMap showing us, these are single symbols applied to these different types of features on the Earth's surface at the nominal categorical level. So a city, a point, church, a block with a cross, for point symbols, examples, lines for roads, streams, utility networks, polygons describing area, different land cover types, desert, water, and forest. So those are all single symbols for single categories at the nominal level. The ordinal level, ordinal is ranked information. So here we're using, at the point level, the same symbol, but different sizes to indicate the rank or the difference in size between those things. Small cities, medium cities, large cities, and we're not necessarily applying an exact value to those, but the size of the symbol implies a ranking order. Highways being lines, there's an ordinal ranking there that's occurring on how much capacity each road has and how much investment and time we put into maintaining those roads as well. Okay. And then we're looking at on the area, so a soil property, soil permeability, which is a measurement of how fast rainwater permeates the surface and then starts percolating vertically downward in the soil. Low permeability, medium, and high permeability. So that's our ranking. Okay, so those we use unique values for each of those different levels in the ranking. Okay, the different levels in the order, and that's what ordinal comes from, is an order. So each one of those ranks has its own symbol, its own color choice, perhaps its own size. And the last for interval ratio data, both of those work kind of the same way. Here we have on point symbols for cities, we can actually apply values with either of these rankings, and not just being words that are describing small, medium, and large. Now we're saying, well, 10,000, 25,000, 50,000. The size of the symbol directly relates to a numerical count of information at the Earth's surface. So this is something, anyway, that's what's happening there. We're looking at line features, intervals of contours, the amount of flow in a river. So those are slightly different ways of showing things. The contours are showing an equal interval of elevation change across space, with each successive line getting higher and higher up on the landscape, up towards ridges and mountaintops. The other symbol that's being shown there is flow, so we're using the size of the line to indicate the rate of flow in the river. And as more streams are coming together, we get more flow in the river. So near the top of the headwaters, 2 cubic feet per second, lower 3, 4 cubic feet more and more volume. So we're seeing the line growing larger and larger to indicate more and more river flow, a quantitative measure of river flow occurring in that linear symbol. For area, something that's common here on the Palouse, looking at crop yields. So the color indicating a measurement of how many bushels per acre are being produced off of that land parcel, that agricultural land. Okay. And so in ArcGIS, that one of the things we can use there is a graduated color, graduated symbols, or proportional symbols to show those differences on the map. Okay, so hopefully, this is making some sense, linking those statistical concepts of different levels of measurement to different types of phenomena that geographically occur out on the Earth's surface, things that we need to show on our maps, depending on the purpose of the map, of course, whether or not we need to include these various things. But hopefully this gives you an idea how that we make those connections between the pure statistics, the pure numbers, or categories, ranking ideas, and the symbolization that we can use on the map. Since humans are very sensitive to color, it makes sense to use it as much as we can, and we can easily use it to describe different levels of measurement, again, as we saw before. Here we're going to focus in on a couple of facets of that, using HSV, or hue, saturation, and value, as the foundation. Hue meaning color, saturation, which means the intensity or purity of a color, and value is the lightness or darkness of a color. If it's a light color, those are known as tints. If it's a darker color, it's known as a shade. Okay, so those are just some definitions that you can easily find in most textbooks and out on the internet for the HSV model, which is used in most of GIS systems. Okay, so let's focus in on the top part of the slide. Over on the right, we're looking there at category, quantity, and divergence. So if we're applying color to categorical information, and it's pretty much whatever color we want applied to any category. There's no ranking, there's no numerical value involved with that. It's just separating out literally different categories that are equal in importance. So any color scheme you want, as long as it's something that you like, or if it's something that matches what's out there in people's perception of the environment, great. That's cool. Quantity, when we apply it there, we usually apply it where either lighter tones, the tints, are lesser values, lower quantities, and darker tints, or excuse me, darker shades are going to be greater quantities. You can reverse that. It doesn't really matter which way you go, but what happens is there must be a progression. So what we're seeing is a progression here for different tints and shades of red indicating quantity. I'll just make the assumption that the one on the top, the lightest one, would be the least amount of the quantity of whatever variable we're studying. And as we move down, we're getting progressively darker and darker, darker into a shade of red that represents the maximum quantity. So that's an appropriate use of color, going from light to dark within a single hue, within a single color, to represent the range of values. Okay, and either way, it doesn't matter. You can go light to dark, dark to light, as long as that progression is logical and follows. That's an appropriate use of color. What would not be appropriate is to use rainbow and apply a rainbow to a quantity. It doesn't make any sense. A rainbow of colors, like you see in the category column over there, it just doesn't make any sense logically, scientifically, to use that. So when you're dealing with quantitative information, you need to have this very logical progression within a single hue. That's the most appropriate use of color for quantitative variables. Now, a tweak on that is over on the right where we see divergence. Okay, divergence is when there's something important in that variable that we can use maybe two different color ranges at once to display that variable. So if we think about heat, you can display heat measured in degrees Celsius, degrees Fahrenheit, degrees Kelvin. Below the freezing point of water, it might make sense to use blue values or blue colors to indicate coldness and increasing amounts of coldness. And above the freezing point, you might use yellows progressing to red, demonstrating warmer and warmer conditions to really hot conditions. So we can see divergence of color and the use of two different, what we might call color ramps, to show that environmental variable and to show it in a way that is logical. It makes sense. So in that sense, divergence is kind of like applying that idea of the quantity twice with two different colors and two different color ramps that are describing the condition, and there's a logical point in between where we can make the transition in color. All right. So anyway, so here's color, the appropriate uses of them, categorical data, doesn't matter, whatever you want. Quantitative data in a single variable, usually that single color ramp is appropriate. If there's a point in that variable that makes sense to do it, you can apply a divergence between two different color ramps. Again, a really good example is temperature, where freezing temperatures are shown in different colors of blue and warmer temperatures in different colors of red.